In this video, I'm going to verify the Pythagorean theorem using the distance formula. So we've got a triangle, a right triangle on the coordinate plane, same triangle as in the last example or the last video. And this time we know the location of the points on the grid. So this is at 7, 3, and this one up here is at 2, and looks like 2, 7. So we can use the Pythagorean theorem. A squared plus b squared equals c squared, and that's 16 plus 25 equals 41, and the square root of 41 is approximately 6.40. So that will be the length of this side is about 6.4. And now we're going to verify that using the distance formula. Remember that the distance formula is equal, or the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And I'll admit this is a little bit circular because the distance formula is basically the Pythagorean theorem. So it's almost like we're using the Pythagorean theorem to prove the Pythagorean theorem. But here we go. Let's persevere. We want to know the distance between those 2 points. We've got our x1 and x2 right here in blue. That's going to give us our horizontal distance. And we've got our y1 and y2. That's going to give us our vertical distance. So we'll do the difference between x, the difference between y, square them, take the square root, and that'll give us a distance. And if the Pythagorean theorem is true, we should get about 6.4. So here we go. 7 minus 2 squared plus 3 minus 7 squared. All of that underneath the square root. Just doing substitution here. Now let's simplify. 7 minus 2 is 5. 5 squared is 25, so 2 steps together there. 3 minus 7 is -4. -4 is 16 when you square it. So putting 2 steps together there. And of course, that is going to be the square root of 41. So if we further simplify, 25 plus 16 is 41. So the distance equals the square root of 41. And it does, in fact, match up exactly. So the Pythagorean theorem is verified.